Hello, everyone. Welcome to this talk. My name is Lei from S7Commplus SAS security team. And this is my first time standing here at Black Hat. So it is really exciting for me. And of course, maybe with a little nervous. But I guess there are not too many people here, so I think this may weaken my nerves. My presentation is the spear to break the security wall of S7Commplus. So this is my teammate. I think without their help, I cannot stand here at Black Hat. So thanks them a lot. Now the overview. First, introduce what is PLC and a general introduction of Siemens PLCs, and then I will introduce the S7Commplus protocol used in the communication between the Siemens PLC and the PCs like engineer station or HMI or other operator stations. And with the basic knowledge of PLC and the S7Commplus protocol, I will introduce the encryptions that is used in the S7Commplus protocol. I will detail how I found these encryptions and then show the video. This video is about to control the S7-1200 PLCs using S7Commplus protocol. And finally, according to my research, some protections are proposed. Now let's see the related work. At Black Hat 2011 USA, Dylan Beresford shows how to use replay attack to attack the S7-300 PLC. S7-300 PLC uses the S7Comm protocol, and this protocol doesn't have any security protections. At Black Hat 2016 USA, Rafael Spanberg shows a worm lives and runs in the S7-1200 PLC with hardware version 3.0. And this PLC only has a simple mechanic to prevent replay attack. And this talk mainly focuses on the current encrypted S7Commplus protocol. What is PLC? PLC has been widely used in power electrical, petrochemical manufacturing, and other industrials. PLC always has a central processing unit, some I/O modules, and communication modules, and also some process modules like PID and so on. This picture shows a Siemens PLC. According to the different protocols used in Siemens PLCs, we separate Siemens PLCs into three types. S7-200 and S7-300 and S7-400 PLCs, they use the S7Comm protocol. S7-1200 PLC with the hardware version below 3.0 PLCs, they use the early S7Commplus protocol, and this protocol only has a simple mechanic to prevent replay attack. And now the S7-1200 PLC with the hardware version 4.0 and the S7-1500 PLCs, they use the current encrypted S7Commplus protocol. TIA Portal is a configuration and programming software for Siemens PLCs. Engineers can use this software to design logic and program for the process. And also engineers can use this software to download PLCs and run or store PLCs, and also monitor or modify the values of PLCs. Replay attack has been widely used in PLC attacks. We can build a small environment with a PLC, a PC, and a hub. For example, click the stop button on the PC, and then use the packet capture software like Wireshark to capture the packets that communicate between the PLC and the PCs. After the PLC has been stopped, we can use the packet we have already obtained and send these packets back to the PLCs. Then the PLC could be controlled with these packets. And this picture shows the stop PRC packets in sequence. We can see that first is the TCP connection, and then follow the COTP connection. After that is the S7Commplus connection packet. Notice that there are two S7Commplus connection request packets and two S7Commplus connection response packets. After the S7Commplus connection has been done, and we can use the function packet to stop PRC, run PRC, or modify the values. Now we are going to talk about the S7Commplus protocol that's used in the communication between PRC and PCs. The current S7Commplus protocol, including the S7Commplus connection packet and the function packet, that has a similar structure. First, let's see the first connection setup request packet. We know that there are two connection request packets. So let's see the first. We can see the protocol ID in red block. 7.2 means this packet is a S7Commplus protocol. And we can also find the PDO types, the data length, the type, the subtype, the sequence number, and the attribute block. Each attribute block begins with A3 and H2. And finally, the frame boundary for the end of the S7Commplus protocol. And then the first connection setup response packet. It has a similar structure like the connection setup request packet. We should notice that there are object ID in green block, and the connection response value array in pink block. They are different in each connection setup response packet. And this is generated by the PRC, and they are all random values. And now for the second connection setup request packet. And we should notice the session ID in red block and the first connection encryption in blue block and the second connection encryption in pink block. The connection encryptions are different in every connection setup request packet, and we will talk this later. And also the function packet. This here takes the stop PRC function packet, for example. We should notice the encryption part in green block and the session ID in pink block. Now we are going to talk about the session ID. We just said that the session ID is in the second connection request packet and the function packet, and they are different in each packet. And session ID can be calculated by object ID. Object ID is a random value generated by the PRC in the first connection response packet. And use this formula, we can get the session ID. And also, S7Commplus protocol has two encryption parts. We have already mentioned one is in the second connection packet, and the other one is in the function packet. The second connection packet has two encryptions, like the picture shows. And with the basic knowledge of Siemens PLCs and the S7Commplus protocol and the replay attack, with this knowledge, I did the replay attack to control the Siemens S7 1200 PLCs, but I failed. I tried another one, but still failed. The communication is terminated. That is because the encryption used in the S7Commplus protocol. And now we are going to talk about the encryptions. Use reverse debug techniques like WinBug or others. We found these encryptions is calculated by TIA portal through a file named omsp.core-manager.dll. Now for the first connection packet encryption, use the reverse debug tools. We found the algorithm's input parameter is the connection response value array. This value array we have already mentioned. It is in the first connection response packet, and this is generated by the PLC, and these are random values. So use this value array as the input. After a simple XOR algorithm, we call this encryption 1, and we can get the first encryption in the first connection request, in the second connection request packet. And continue reverse debug, we can find the second encryption part in the second connection request packet. Use the first encryption result as the input parameter. Through a more complex Siemens private algorithm, we call this encryption 2, and we can get the second encryption. With these two encryption calculated, we can the connection parts can be finished. Then after the connection part, we can send some function packet, and the function packet also has the encryptions. Also use the reverse debug, use the WinDebug, we can find a constant field array with session ID is the input parameters. And through algorithm, we call it encryption 3. It is also a Siemens private algorithm. And finally, we got the function encryptions. So here is the demonstration. I just write a small program, and with these encryptions, I can control the Siemens S7-1200 PLC with hardware version 4.1. It's just a small environment with just one S7-1200 PLC and a hub and a PC. The green NAND cable connects to the PLC, and the yellow one connects to the PC. First, input the IP address of the PLC. And then the connection part has been finished. And now we can see the PLC's hardware version is 4.1. We can see the run stop light is green. That means the PLC is running. This light is green. And we click the stop button. The light turns to yellow. That means the PLC has been stopped. And then click the run button to run the PLC again. You can see the light turns through green and the PLC is running again. So I just use the S7Commplus protocol to control the S7-1200 PLCs. So that's a demonstration. So let's take an overview of this communication. First is the TCP connection and then the COTP connection. After this, the PC will send the first connection request packet to the PLC. Receiving this packet, the PLC will generate a random value array and a random value named object ID and send this back in the S7Commplus connection response, in the first S7Commplus connection response packet. With the object ID and the random value array, the PC, the TIA Portal software can calculate it with encryption 1 and encryption 2 to the connection packet encryptions and the session ID. With the session ID and the connection encryptions, the PC will send the second connection request packet to the PLC. The PLC will have a verified with the session ID and the encryption part. If this was verified correctly, and the PLC will send back the second connection response packet. After the connection has been finished, the PC can send the function packet with the function encryptions, and the function encryptions are calculated by the session ID through an algorithm we named encryption 3. And receiving this packet, the PLC will have verified again. If the encryption part has been verified correctly, and the PLC can be controlled by this packet. So this is the whole process. And finally, I will propose some protections. First, in code level, TIA Portal and maybe other industrial software, they didn't use any code confusion techniques and anti-debug techniques. That is why I can easily break the protocol, the encryptions. And the second one, in design level, Siemens has provided a function named protection. And this means users can set a password to the PLC. And if you want to control the PLCs like stop PLC, run PLC, or write values, you should enter the password first. But this is not necessary. And as far as I know, most of the users doesn't have this password. And the third one, in protocol level, I suggest to encrypt the whole packet instead of just some key byte. So this is my presentation. Thank you. And any questions?
Okay, we still have 10 minutes for Q&A.
Hi, thanks for the presentation. Did you report the issues to Siemens, and if so, what was their reaction?
Maybe no. Yes, I will. After the black hat, maybe I will tell Siemens.
Next question.
Will you be releasing the code?
No,
Open source? No?
No, I won't. Maybe PLC is maybe after Siemens fix this, I can release the tools.
Hi, thanks for the talk. I have a question about the encryption because there's something I didn't really get, I think.
Okay.
So the PLC, is it correct that the PLC generates some random values, sends it over to the, in this case, the PC?
Yeah, yes.
And then the PC uses some secret encryption algorithms and that key to encrypt some parts of the packages. So there's no real key exchange or something. There's just the PLC generating random values, and these are the keys used for encryption. That's all of the design of the encryption design, right?
Yes.
Okay. 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 Thank you. It's as bad as I thought. Thanks.
Hi, this is Phil from CyberX. What do you think Siemens' motivation was for doing it in this less than ideal way? I mean, they must have. Is it a question of processing power on the PLC? Is it memory, you know, that kind of thing, or is it?
Maybe I think it is not easy to fix because this has been widely used in Siemens PLCs and in industrial factories. It is not easy to update. So.
Sure, it's not easy to update, but when they designed this encrypted version of the protocol, they were doing something new.
Yeah. Yes, maybe they should get better for new protocol, I think.
Okay, thanks.
Next question, right? Does anyone has a question?
How long has this proprietary encryption scheme been used in Siemens products?
How long this protocol has been used?
The encryption, is that specific to this version of the hardware, or is it the proprietary encryption scheme that used by Siemens over the period of many years?
No, I think just maybe 4 or 5 years. In 2010, the Stunknex, everyone knows that, it has not used the new encrypted protocols. Maybe after that, Siemens has proposed this protocol. I think maybe 4 or 5 years ago.
Yeah, thank you. Wonderful presentation. I just have one question. Do you work on any other brands of PLC, such, for example, Schneider Electric or, you know, ABB?
Yes, that's what I'm doing now.
Okay.
I try to break the protocol of Schneider and AB, the Logaware.
Okay.
Yeah.
Thank you.
Next question.
Would it be possible to monitor and detect this type of attack on a network layer?
Sorry?
On a network layer, would it be possible to monitor and detect this type of attack replaying using those encryption keys to back to the PLC?
Sorry, I can't follow.
So what I'm asking is, you are capturing that packet,
Yeah.
and replaying, sending it back to the PLC. So what I'm saying is it possible to monitor that on a network layer to say you are replaying that packet with those keys that we're sending back to the PLC? Do you think that's possible?
Maybe the S7-1200 PLC with the new hardware version, it is not possible because of the encryption. But if there are no encryptions, it is possible.
Just specifying your question, it's not possible to find in the Wireshark which kind of packets you say send to the PLC and which kind of commands or requests PLC sends back. So because the function blocks are encrypted and we can't find, is it a stop command or is it a start command sending from the SCADA system, for example, to PLC? Because the encryption, and it is by design. Okay.
Yes, I suggest to try more times.
Thank you.
Thank you. Does Siemens release the newest protocol that implements some better security features, or this is the latest version that we have?
It is.
Is this the latest version of the protocol that we have, or?
Yeah.
Okay,
Yes,
thank you.
the latest.
Thank you very much.
Does your company do anything in this area of ICS security, or what? I'm just wondering what is the how this research is important to your company.
Yes, my company does research on ICS security research.
And do you have products in that space?
Yes.
Like firewalls or?
Firewalls, yes. And others, IDS, IPS, and the scan facility device.
Scan devices.
Yes, and the fast device.
Sorry, which one?
Fuzzing device.
Fuzzing, got
Yeah.
it. Okay, thank you.
So, hi, thank you for the presentation. I was wondering, don't you think you should have probably disclosed this to Siemens before you presented today? Because this might have some serious implications for them.
Yes, maybe.
Just for future reference. There may be some implications, I'm not sure, but it seems pretty doable. So.
No question. Nice. Okay, no more questions.
Okay, thank you for attending.